Hi guys, tonight we're going to explore one of the most terrifying cosmic scenarios imaginable. What if Earth suddenly broke free from its orbit around the Sun? What if our planet, after faithfully circling our star for 4.5 billion years, just started drifting into the void of space, carrying all of us with it? If you enjoy these catastrophic deep dive sleep stories that explore the most extreme what-if scenarios, hit that like button and subscribe for more, and drop a comment letting me know what time it is where you are and where you're listening from. It's always great to see where you're all winding down from around the world. Alright, let's begin. The morning sun rises over New York City as 8 million people begin their daily routines, unaware that in the depths of space something impossible has just occurred. Earth, our blue marble home that has faithfully circled the sun for 4.5 billion years, has suddenly broken free from its gravitational bonds. The planet that travels at 67,000 miles per hour in its eternal dance around our star has just begun a journey into the cosmic void, carrying every living thing with it toward an uncertain fate. To understand the magnitude of this catastrophe, we must first grasp the delicate balance that keeps our world in its life-sustaining orbit. Earth maintains its position around the Sun through a precise equilibrium between the star's gravitational pull and our planet's forward momentum. The Sun, with a mass of 2 × 10 to the 30th power kilograms, exerts a gravitational force that keeps Earth locked in an elliptical path that varies between 91 and 94 million miles from its surface. This distance, known as an astronomical unit, represents the perfect zone where liquid water can exist, where temperatures allow for the complex chemistry of life, and where the delicate atmospheric conditions that support our biosphere can persist. But now, in this impossible scenario, that cosmic tether has been severed. Perhaps a rogue black hole, invisible to our telescopes, has passed through our solar system, its immense gravitational field overwhelming the Sun's hold on our planet. Or maybe some unknown force, operating beyond our current understanding of physics, has simply switched off gravity's influence between Earth and its parent star. The cause matters less than the consequence. Earth is now hurtling through space in a straight line, carrying its 7.8 billion human inhabitants and countless other species into the frozen darkness between the stars. The first signs of our planet's liberation from solar orbit would be subtle, almost imperceptible to the average person. Astronomers at observatories from Mauna Kea to the European Southern Observatory would be the first to notice the change. The familiar patterns of stellar motion would shift slightly. The Sun's position in the sky would begin to drift from its predicted path, and sensitive instruments would detect that Earth's orbital velocity has suddenly become escape velocity. The planet that once traced a predictable ellipse around the Sun now follows a hyperbolic trajectory toward interstellar space. Within hours, the most sophisticated computer models at NASA's Jet Propulsion Laboratory would confirm humanity's worst fears. Earth has broken free from the Sun's gravitational well and is travelling at approximately 70,000 miles per hour relative to the solar system. At this speed, our planet will cover the distance from Earth to the Moon every 3.5 hours. But unlike our faithful lunar companion, we are not coming back. The immediate effects would be surprisingly minimal. Earth's rotation would continue normally, giving us the familiar cycle of day and night. The planet's magnetic field, generated by the motion of molten iron in its core, would remain intact, continuing to shield us from cosmic radiation. The atmosphere, held in place by Earth's own gravity, would stay with us on our journey. For the first few days, perhaps even weeks, life on Earth would continue much as it always had, with many people unaware that anything had changed at all. But the Sun, that nuclear furnace that has powered life on Earth for billions of years, would begin to shrink in the sky, Currently, our star delivers approximately 1,361 watts of energy per square meter to the top of Earth's atmosphere. This solar constant, as it's known to scientists, drives our weather systems, powers photosynthesis, and maintains the delicate temperature balance that keeps our oceans liquid. As Earth moves away from the Sun, this energy input would decrease according to the inverse square law. At twice our current distance, we would receive only 1/4 of the solar energy. At 10 times the distance, just 1/100th. The first critical threshold would be crossed when Earth moves beyond the orbit of Mars, approximately 140 million miles from the Sun. At this distance, the solar energy reaching our planet would be reduced to about half its normal level. The global average temperature, currently a comfortable 59 degrees Fahrenheit, would begin its inexorable decline. The effects would not be uniform across the globe. The equatorial regions, which currently bask in intense sunlight, would see the most dramatic cooling, while the polar regions might initially experience less dramatic change, being already adapted to minimal solar input. Agricultural regions that feed the world's population would face the first crisis. The wheat fields of Kansas, the rice paddies of Southeast Asia, and the corn belt of the American Midwest all depend on precise levels of solar radiation for photosynthesis. As Earth moves beyond the asteroid belt, roughly 250 million miles from the Sun, these crops would begin to fail en masse. The growing seasons that have fed civilization for millennia would become untenable. India, which produces over 100 million tons of rice annually, would see yields plummet. The United States, responsible for 40% of the world's corn production, would face agricultural collapse. But it would be the planet's forests that would provide the most visible sign of our changing circumstances. The Amazon rainforest, spanning 2.1 million square miles, and containing an estimated 390 billion trees, would begin to die as solar energy levels dropped below the threshold necessary for tropical photosynthesis. These trees, which currently absorb approximately 2 billion tons of carbon dioxide annually, would stop their vital work of oxygen production and carbon sequestration. The boreal forests of Canada and Siberia, covering millions of square miles, would face similar extinction as the shortened growing seasons and reduced solar input made their survival impossible. As Earth passes the orbit of Jupiter, approximately 484 million miles from the Sun, the solar energy reaching our surface would be reduced to just 4% of normal levels. The Sun, once a brilliant disk that could blind the naked eye, would now appear as nothing more than a bright star among countless others. The psychological impact on humanity would be profound. For all of human history, the Sun has been a constant presence, rising each morning and setting each evening. Now it would become increasingly difficult to distinguish from other bright stars, a visible reminder of our species' journey into the cosmic wilderness. The global climate system, powered by solar energy, would begin its complete breakdown. The great ocean currents that distribute heat around the planet would weaken and eventually stop. The Gulf Stream, which carries warm water from the Caribbean to Western Europe and maintains the moderate climate that supports a population of over 700 million people, would cease to flow. London, currently enjoying average winter temperatures around 40 degrees Fahrenheit due to this oceanic conveyor belt, would experience Arctic conditions. The monsoon systems that bring life-giving rains to billions of people in South and East Asia would fail completely as the temperature differentials that drive these weather patterns disappeared. Weather itself would become increasingly irrelevant as Earth cooled. The water cycle, driven by solar heating of the oceans, would slow dramatically. The evaporation that lifts billions of tons of water into the atmosphere daily would decrease proportionally with solar input. Cloud formation would diminish. though this would provide little comfort as the reduced greenhouse effect from water vapour would only accelerate the cooling process. Eventually, as temperatures dropped below freezing across most of the planet's surface, precipitation would fall only as snow, accumulating in ever-deepening layers that would never melt. The world's cities would become the last refugees of human civilization. Urban heat islands, created by the concentration of buildings, vehicles, and human activity, would provide temporary respite from the cooling world. New York City, with its 8.4 million residents generating heat through metabolism, industry, and burning fossil fuels, would remain warmer than the surrounding countryside. The subway systems, naturally insulated underground, would become valuable spaces. London's underground, Moscow's metro, and similar systems in cities around the world would transform from transportation networks into potential survival shelters. Power generation would face unprecedented challenges. Solar panels, which currently provide over 3% of global electricity, would become increasingly useless as solar irradiation levels plummeted. Wind power, dependent on temperature differentials that drive atmospheric circulation, would decline as the Earth's weather systems weakened. Hydroelectric power, relying on the water cycle driven by solar evaporation, would gradually fail as rivers froze solid. The world would become increasingly dependent on nuclear power, geothermal energy, and fossil fuel combustion for electricity generation. Nuclear power plants, which currently generate about 10% of global electricity from 440 reactors worldwide, would become humanity's most valuable energy assets. Countries like France, which derives 70% of its electricity from nuclear sources, would find themselves at a significant advantage in the cooling world. The uranium fuel rods and thorium reserves that power these plants represent energy that is independent of the sun, drawn from the radioactive decay of heavy elements forged in ancient stellar explosions billions of years ago. As Earth crosses the orbit of Saturn, approximately 886 million miles from the Sun, the solar energy reaching our planet would drop to just 1% of normal levels. At this distance, the Sun would be indistinguishable from other bright stars to the naked eye. Daytime would be little brighter than a moonlit night on the old Earth. The psychological impact of perpetual twilight would be devastating. Seasonal affective disorder, which currently affects millions during winter months, would become a global pandemic as the entire human population found themselves trapped in endless dim conditions. The oceans, which cover 71% of Earth's surface and contain 97% of all water on the planet, would begin their transformation into ice. Starting from the poles and working toward the equator, sea ice would advance relentlessly. The Arctic Ocean, already partially frozen each winter, would become solid ice year-round. The Antarctic ice sheet, currently containing 26.5 million cubic kilometers of ice, would expand dramatically as ocean water froze and accumulated on its edges. Marine ecosystems would collapse in cascading waves. Phytoplankton, the microscopic organisms that form the base of oceanic food chains and produce over 50% of the world's oxygen, require sunlight for photosynthesis. As solar energy levels dropped, these crucial organisms would die en masse. The whale populations that depend on krill, which in turn feed on phytoplankton, would face starvation. The fishing industries that provide protein for billions of people would collapse as fish populations plummeted and fishing grounds became inaccessible due to ice cover. Coastal cities would face a unique crisis as the expanding sea ice began to affect ocean levels and coastal dynamics. The freezing of ocean water would initially cause sea levels to drop slightly, as ice is less dense than liquid water. However, the expansion of polar ice sheets onto previously ice-free ocean areas would eventually outweigh this effect. Cities like Venice, already struggling with rising sea levels, would find their problems transformed as canals froze solid and storm surges were replaced by the advancing edge of permanent sea ice. Food production would face complete transformation. Traditional agriculture would become impossible across most of the planet as soil temperatures dropped below the minimum requirements for plant growth. Greenhouse agriculture, already representing billions of dollars in global food production, would become humanity's primary food source. The Netherlands, with over 4,000 hectares of greenhouse agriculture, currently producing over $4 billion worth of crops annually, would provide a model for survival. However, even greenhouse production would require enormous amounts of energy to maintain growing temperatures, putting additional strain on dwindling power supplies. Innovative food production methods would become essential for survival. Hydroponic systems, which currently produce crops in controlled environments using nutrient solutions instead of soil, would proliferate. Vertical farms, already operating in cities around the world, would become crucial infrastructure. The largest vertical farm currently operating in Japan covers approximately 45,000 square feet and produces over 10,000 heads of lettuce daily, using 99% less water than traditional farming. Such facilities would need to be scaled up massively to feed surviving populations. As Earth travels beyond the orbit of Uranus, approximately 1.7 billion miles from the Sun, solar energy would be reduced to just 1/4% of normal levels. The Sun would now appear as merely a bright star, providing no meaningful heat to Earth's surface. Surface temperatures would plummet to levels where carbon dioxide, which makes up approximately 400 parts per million of Earth's atmosphere, would begin to freeze out of the air at -109 degrees Fahrenheit. The familiar blue sky would darken as the atmosphere thinned and dust particles were no longer suspended by thermal currents. The planet's water cycle would effectively cease. The last clouds would disappear as atmospheric water vapor froze and fell as snow. The great rivers that have sustained human civilization would freeze solid from surface to bottom. The Amazon River, which discharges approximately 200,000 cubic meters of water per second into the Atlantic Ocean, would become a highway of ice. The Nile, the Mississippi, the Yangtze, and every other river on Earth would join this transformation, their flowing waters locked in crystalline stillness. Human society would undergo radical transformation. The global economy, based on trade between nations and regions, would collapse as transportation became increasingly difficult and energy costs soared. The shipping industry, which currently moves over 11 billion tons of cargo, annually worth trillions of dollars, would cease operations as ports froze over and fuel became too precious to use for commerce. International flights would become impossible as jet fuel froze in aircraft systems and runways became unusable due to ice accumulation. Cities would become isolated islands of survival in an increasingly hostile world. The Tokyo metropolitan area, home to 38 million people and generating over $1.9 trillion in economic output annually, would need to become completely self-sufficient. Supply chains that currently bring food, fuel, and manufactured goods from around the world would fail completely. Urban agriculture would need to expand dramatically to feed concentrated populations, while industrial production would focus entirely on survival necessities. Energy conservation would become the paramount concern for human survival. The average American currently uses approximately 450 gigajoules of energy annually, equivalent to about 7 tons of oil. In the cooling world, this consumption would need to be reduced dramatically and redirected entirely toward essential needs: heating, lighting, food production, and basic industry. Waste heat from any source would become valuable. Data centers, which currently consume about 1% of global electricity and generate enormous amounts of waste heat, would be redesigned to serve dual purposes as both computing facilities and building heating systems. Underground spaces would become increasingly valuable as surface conditions deteriorated. Natural geothermal activity would provide the last sources of heat independent of human technology. Areas near geothermal features, such as Iceland with its abundant hot springs and volcanic activity, or Yellowstone National Park with its extensive geothermal field, would become crucial refuges. Iceland, already generating over 25% of its electricity from geothermal sources, would find its unique geology invaluable for survival. The Yellowstone geothermal system, powered by a massive underground magma chamber, generates enough heat energy to power the entire United States many times over. While harnessing this energy directly would be challenging, areas near geothermal features would remain above freezing, even as the rest of the planet cooled to unlivable temperatures. Communities would cluster around hot springs, geysers, and volcanic vents, creating a new geography of human settlement based on access to Earth's internal heat rather than solar energy. As our planet travels beyond Neptune's orbit, approximately 2.8 billion miles from the Sun, we would enter the realm of the outer solar system where solar energy is virtually non-existent. The Sun would appear as nothing more than a point of light, providing no more warmth than any other star. Surface temperatures would drop toward absolute zero, approximately minus 460 degrees Fahrenheit, limited only by the small amount of heat radiating from Earth's core and the decay of radioactive elements in the planet's interior. At these temperatures, the very air would begin to freeze. Nitrogen, which makes up 78% of Earth's atmosphere, would condense into liquid at minus 320 degrees Fahrenheit and freeze solid at minus 346 degrees Fahrenheit. Oxygen would liquefy at minus 297 degrees Fahrenheit and solidify at minus 361 degrees Fahrenheit. The atmosphere that has protected and sustained life for billions of years would literally rain down as liquid and eventually snow as solid chunks of frozen air. This atmospheric collapse would create a surreal landscape unlike anything in human experience. The air pressure that currently measures approximately 14.7 pounds per square inch at sea level would drop dramatically as gases condensed out of the atmosphere. Mountains would be covered in drifts of solid nitrogen and oxygen, creating an otherworldly scene of coloured snow and ice formations. The northern lights, currently caused by solar particles interacting with our magnetic field, would disappear as the solar wind no longer reached our planet. Yet even in this frozen hellscape, life might persist in unexpected places. Deep in the ocean, hydrothermal vents would continue to function, powered by Earth's internal heat rather than solar energy. These underwater oases currently support unique ecosystems of bacteria, tube worms, and other organisms that derive energy from chemical processes rather than photosynthesis. The vents, which spew water heated to over 700 degrees Fahrenheit by contact with volcanic rock, would remain active even as the ocean surface froze solid. Some scientists theorize that complex life might survive near these vents even without solar energy. The giant tube worms found at deep-sea vents, some reaching lengths of 8 feet, depend entirely on chemosynthetic bacteria for nutrition. These ecosystems process approximately 500 billion tons of carbon annually through chemical rather than solar energy, demonstrating that life can exist independently of our star. However, the freezing of the entire ocean would eventually isolate these vents beneath miles of solid ice, making their long-term survival questionable. Earth's core would continue generating heat through radioactive decay for billions of years. The planet's interior, heated by the decay of uranium, thorium, and potassium isotopes, maintains temperatures of over 9,000 degrees Fahrenheit at the core, hotter than the Sun's surface. This heat slowly conducts toward the surface, creating the geothermal gradients that power hot springs and volcanic activity. Even as the surface froze completely, this internal heat source would persist, offering the theoretical possibility of survival for any life forms that could access it. Human survival in such conditions would require complete transformation of our civilization. Surface living would become impossible, forcing humanity underground. The deepest inhabited spaces on Earth currently reach only a few hundred feet below the surface, but survival would require going much deeper to access geothermal heat. The Mponeng gold mine in South Africa, currently the world's deepest mine at over 12,000 feet below the surface, reaches rock temperatures of 140 degrees Fahrenheit due to geothermal heating. Creating livable underground cities would require enormous engineering efforts and energy resources. The excavation of sufficient space to house millions of survivors would demand massive amounts of mechanical energy, while the construction of life support systems capable of recycling air, water, and waste in closed environments would push human technology to its limits. The International Space Station currently supports a crew of 6 people using highly sophisticated life support systems that cost billions of dollars to develop and maintain. Scaling such systems to support millions of people would be humanity's greatest engineering challenge. Food production in this underground world would rely entirely on artificial lighting and carefully controlled growing conditions. LED grow lights, which currently enable indoor agriculture using approximately 40 watts per square meter, would need to be powered by the dwindling energy resources available to surviving communities. The energy cost of producing food would increase dramatically, as plants would receive no free energy from the sun. Every calorie of food produced would require multiple calories of energy input for lighting, heating, and environmental control. Water resources would face transformation as well. While the planet's total water supply would remain unchanged, accessing liquid water would become increasingly challenging as surface sources froze. Geothermal areas would provide the only naturally occurring liquid water, making these locations invaluable for human settlements. The water cycle that currently purifies and distributes fresh water through evaporation and precipitation would cease completely, requiring technological solutions for water treatment and distribution. As Earth continues its journey through interstellar space, traveling at 70,000 miles per hour, our planet would eventually leave the solar system entirely. The heliopause, the boundary where the sun's influence ends and interstellar space begins, lies approximately 11 billion miles from the sun. At Earth's escape velocity, we would cross this boundary after approximately 17 years of travel. Beyond this point, our planet would be truly alone in the cosmic void between stars. The nearest star to our sun is Proxima Centauri, located approximately 4.2 light-years away. At Earth's current trajectory speed, it would take over 40,000 years to travel this distance. However, the gravitational influence of other stars would eventually alter Earth's path, potentially capturing our planet in orbit around a new stellar parent. The chances of finding a star similar to our Sun at the right distance to support life are astronomically small but not impossible. Throughout human history, civilizations have risen and fallen due to climate changes, resource depletion, and natural disasters. The Roman Empire declined partly due to a cooling climate period that reduced agricultural productivity. The Maya civilization collapsed during extended drought periods that made their cities unsustainable. The Black Death killed 1/3 of Europe's population in the 14th century, yet human civilization survived and eventually thrived again. However, Earth's departure from the solar system would present challenges unlike any faced in human history, requiring adaptations and technologies that would fundamentally transform our species. Some survivors might adapt to the underground existence, developing new technologies for deep Earth living and eventually thriving in geothermally heated cities beneath the frozen surface. Others might focus on developing space travel capabilities, using Earth's remaining energy resources to launch expeditions toward other star systems in hopes of finding habitable worlds. The James Webb Space Telescope has already identified thousands of exoplanets in the habitable zones of distant stars, proving that Earth-like worlds exist elsewhere in the galaxy. The irony of Earth's escape from the solar system is that it might ultimately force humanity to become a truly spacefaring civilization. Currently, over 99.9% of humans live on Earth's surface, completely dependent on our planet's resources and solar energy. The crisis of losing the sun might drive technological developments that enable human expansion into the galaxy, spreading our species across multiple star systems and ensuring survival even if individual planets face catastrophic events. Nuclear propulsion systems, currently in experimental stages, could be scaled up to power interstellar missions. Project Breakthrough Starshot aims to send small probes to nearby star systems using light sails propelled by lasers, achieving speeds of 20% of light speed. While human interstellar travel would require much larger and more sophisticated spacecraft, the urgency of Earth's situation might accelerate development of such technologies by decades or centuries. The frozen Earth itself would become a unique repository of terrestrial life, preserving millions of species in a natural deep freeze that could potentially last for millions of years. Every ecosystem, from tropical rainforest to Arctic tundra, would be perfectly preserved at the moment of freezing. If Earth were eventually captured by another star and warmed again, this biological archive might allow the restoration of terrestrial ecosystems with their original genetic diversity intact. Advanced civilizations, if they exist elsewhere in the galaxy, might even detect Earth's unusual journey through interstellar space. A planet-sized object traveling at high speed between star systems would be detectable by sufficiently advanced astronomical instruments. Such civilizations might interpret Earth's trajectory as evidence of intelligent life attempting to escape a dying star system, potentially leading to first contact scenarios that could transform human understanding of our place in the universe. The financial cost of human survival in this scenario would be unprecedented. Current global GDP totals approximately $90 trillion annually, but in a world without conventional agriculture, commerce, or industry, traditional economic systems would become meaningless. Resource allocation would be based on survival priorities rather than market mechanisms. The most valuable commodities would be energy sources, food production capabilities, and materials for constructing underground habitats. Even as conventional civilization collapsed, human knowledge and culture would require preservation for future generations. Digital storage systems would become crucial repositories of human achievement, from scientific knowledge to artistic works. The Internet Archive currently stores over 730 billion web pages and millions of books, representing a significant portion of human knowledge. Maintaining such systems would require precious energy resources, but would be essential for preserving civilization's intellectual heritage. The psychological challenges of survival would be as daunting as the physical ones. Humans have evolved under the daily rhythm of sunrise and sunset, the seasonal changes driven by Earth's orbit, and the comfort of seeing familiar stars in predictable patterns. In the underground cities of the cooling world, artificial lighting would need to simulate natural day-night cycles to maintain human circadian rhythms. The absence of seasons, weather patterns, and natural environmental changes would require carefully designed psychological support systems to prevent widespread depression and social breakdown. Education systems would face complete transformation. Children growing up in underground cities would need to learn about the surface world they would never see, the sun that once warmed their planet, and the natural systems that sustained life for billions of years. Virtual reality systems might become essential tools for teaching about Earth's former glory, allowing young people to experience simulated forests, oceans, and blue skies that no longer exist on their world. As decades pass and Earth travels deeper into interstellar space, the survivors would face the ultimate question of human identity. Are we inherently creatures of Earth, dependent on solar energy and natural ecosystems for our existence? Or can we adapt to become something new, a species capable of surviving in the cosmic void between stars? The answer would determine not just the survival of individual humans, but the future evolution of our species across cosmic timescales. The departure of Earth from its orbit represents the ultimate test of human ingenuity, cooperation, and will to survive. It would strip away everything we consider normal about existence and force us to discover what is truly essential about being human. In the depths of space, surrounded by the frozen remnants of our former world, the survivors would need to create new meaning, new purposes, and new ways of living that could sustain human civilization through the long journey to whatever destination awaits among the distant stars.